सपने वो नहीं होते जो आप सोने के बाद देखते हैं, सपने वो होते हैं जो आपको सोने नहीं देते। Let's twist it a bit. आराम से सोना, सपने भी देखना और उसे साकार भी करना। नई सुबह है, नई उम्मीद, नया दिन है, नया सेशन। आज के इस सेशन में सभी का स्वागत है। Esteemed guest, director sir, principal sir, learned colleagues and dear students, a very warm welcome to you all. We have covered 5 days of the Student Induction Program 2024 with an aim to help new students adjust and feel comfortable in the new environment, inculcate in them the ethos and cultures of the institution, help them build bonds with other students and faculty members, and expose them to a sense of larger purpose and self-exploration. As John C. Maxwell once said, the only limit to our realization of tomorrow is our doubts of today. I am confident that our program has been instrumental in addressing those doubts and empowering our students to embrace their journey with confidence and enthusiasm. Today, we continue this journey with yet another enriching day. It's my pleasure to invite the dignitaries onto the stage. So please. I would like to request Principal Sir to extend a warm welcome to our esteemed guest. Thank you, sir. It is with great honor and excitement that I introduce our speaker of the day, Dr. Padmalochan Bera. After graduating from Jadavpur University, he did his master's from the West Bengal University of Technology, Kolkata, and completed his doctorate from IIT Kharagpur. His research areas include network and system security, advanced cryptography, software-defined networks, access control, security testing, formal verification, and optimization. Currently, he is working as Associate Professor in the Department of Computer Science and Engineering in IIT Bhubaneswar. Earlier, he worked for Infosys Labs Bangalore, General Motors of India Science Lab Bangalore, Cyber DNA Research Center North California under various capacities. He has published more than 70 research papers in reputed journals. Dr. Bera served in the editorial board and organizing committee of various journals and conferences and has research collaborations with various international academic institutes such as University of North Carolina, University of Illinois, Carnegie Mellon University, University of Missouri, Oxford University, and Florida International University. We are honored to have such a distinguished scholar with us today. If I say it's going to change everything more than the internet has, what is it? Blockchain. Yes, it is the topic of the day, the blockchain and its applications. Without further ado, may I now hand over the stage to you, sir.
Am I audible? Okay. So, very good morning to all of you. Uh, Good morning. So, it's my pleasure to uh, be here today to share some of the upcoming technologies in the field of computer science with you. Okay. So, as I mentioned that upcoming fields, okay, or emerging technologies. So, you might be obviously thinking about artificial intelligence and machine learning, which is very uh, emerging technology, and lot of people are basically talking about this. Okay, but you must be also hearing that there are this technology is facing certain challenges these days, where basically security and privacy of machine learning models or artificial intelligence techniques, they are facing serious challenge these days. Okay, where you have huge volume of data, and these data you will be generated by various systems, and it basically stored in different data sources, and when these data are basically shared across machine learning models, right? So there is a significant challenge that whether the privacy or secrecy of the data is maintained. Okay, this is a serious challenge, and in fact in that directions you might be seeing there are various solutions also researchers and industries are looking into, like cryptographic techniques such as homomorphic encryption. Then there are modified machine learning techniques, or advanced machine learning techniques like federated learning, which have also been evolved, where as much as possible data can be kept with the data owner. It cannot be exposed to the server side, where basically the models are actually computed. I mean, the computations are performed. Okay, machine learning computations are performed mostly in the server side. So there, uh, you know, uh, data may not be exposed to the server. So such way, like federated learning models has evolved, then homomorphic encryptions. There are another very emerging solutions, that is secure multi-party computations, where distributed nodes, they can actually uh, participate in training the machine learning models. Okay, so it is called collaborative learning, where multiple nodes, they basically share the parameters, not exactly the data. Data is kept with the nodes itself. So some parameters they share, exchange amongst themselves. In the process, overall machine learning computations that can be achieved. Okay, so in the similar directions, this is something blockchain, which is a very important tool actually to support machine learning models these days. Though when it was introduced, blockchain was introduced, so that time there was no linkage between machine learning and blockchain. So today I will try to show you also later stage that how blockchain can be used as a tool to make our ML applications more secure and privacy preserved. Okay. So okay, so let us start with. So how many of you have taken database systems course? Database management systems course in computer science. Okay, many of you. Okay. How many of you have taken data structure, hashing in data structure, hashing part? I mean, in data structure, many topics are covered: trees, linked list, queue, stack. How many of you have taken hashing, read hashing? Oh, they are first year students. Oh, okay. Sorry. So, okay. So, all right. So, this blockchain technology, you might be saying that, oh, okay, this is a very fascinating technology. So, we should really go deeper into it. But when we go deeper into it, before we understand blockchain, there are fundamentals of computer science. So, behind blockchain, it is basically fundamentals of computer science is there. So, there is uh, database management system, and there is hashing, and there are some mathematics, basically we call it as cryptography. So, these fields, these three fields together, one is data structure, second one is database management system, and third one is discrete mathematics. These three fields together actually brought this particular technology into the picture. So, blockchain. So, as you know, in case of databases, so suppose what you do, in the bank there are in a particular bank there are multiple accounts, right, and these account informations are maintained, and then there are various types of transactions like withdrawal of money, deposit, then transfer of fund, right. There are various types of applications. So, how these applications can be maintained by the server in which is maintained by the corresponding bank, right. So, obviously, when we think about that, maintaining so many huge number of such records, every day there are thousands of transactions are happening, right, different types of transactions in the bank account, and we need to store all these transaction informations in a scalable manner. Scalable manner, when we say that we should able to allow storage of large number of transactions, right. So, because there might be many customers, I mean bank cannot deny allowing like opening of accounts or doing various types of transactions for any random customer, right. It should be allowed. So, in that case we want to say that say large number of transactions needs to be stored, and when these transactions are stored, informations are stored in a particular server, let us say in a particular server model, then next question is what type of operations we can allow, what type of operations can be allowed to manipulate the data, these transaction details which are available in the server, which are stored in the server. So, first question is storage, appropriately storage of all these data in a server, and second question comes that what type of operations that can be allowed on this data, right. So, obviously we might be saying that okay, so the what type of operations that can be performed. So, you might say that okay, I may insert a new record, I may insert a new transaction, tomorrow another transaction has performed by another user of bank account, then that corresponding record has to be inserted in the server. I may insert new record, okay, in the server. Then what else? I may want to update, I may want to update informations of some of the account, okay. So, some accounts are already there, or some transactions are already there, I want to change the amount or something, balance, some updates we want to do. So, this is also possible, inserting new records, updating existing values which are stored in the server. What else? I may be interested that there are huge logs, so some of the logs are basically redundant, some of the records are redundant, I may be interested to delete. I may be interested to delete some information from the records, okay, from the store. Finally, I may interested to read the data. Read means just only accessing, let us say I want to see that what is the in a particular period, during a particular period, what is the volume of transactions in a particular bank branch. So, I want to see that, I want to aggregate some of the records, and based on these records I want to calculate that what is the volume of transactions that have been performed on during a particular period. So, that is also possible. So, this is basically reading of data. Now, if this whole thing is this data which I said that transactions of different banks, bank accounts, if these are stored in a centralized server. What do you mean by centralized server? There is a single server which is storing everything. So, what is the challenge in that, or what are the advantage in that? So, I am saying that these all transactions across different branches are happening through different applications, and in a particular bank, let us say SBI has hundreds of branches, thousands of branches. Across all branches there are many transactions, all are being stored in a single server. Okay. So, if I store this in a single server, all these informations, what are the advantages? Anyone? What are the possible advantages? So, advantages is what? Consistently you can maintain, right, information. So, for example, if some informations are updated by one application, so two applications are simultaneously trying to update some informations, two applications. What type of two applications? Let us say there is an account and you are transferring fund from your account to another account. At the same time you are withdrawing some money from your account. Look at these two transactions are trying to update the same account information. So, your account has, let us say 10,000 balance, and you are transferring money from your account to another account, let us say 5,000 rupees you are transferring, and another application which is withdrawing money from your account, that is amount, let us say 8,000, but your balance is 10,000. Now, these two transactions are basically a software application, right? Two software applications are simultaneously being executed and it is being performed on the same data, same account, right? So, in such cases, obviously, if you have centralized kind of server, so obviously you can apply some synchronization mechanism or some kind of concurrency mechanism to ensure that, okay, these data are consistently, these two applications are consistently performed, right. So, one after another, so that the final balance should be correct, not incorrect. Okay. So, this is one advantage. Another advantage is that if we want to make the data secure completely, then centralized model is good. Centralized model, they are basically, you can propose, you can use different types of techniques, security enabling techniques, to ensure that these data integrity is maintained significantly. So, nobody is tampering this data, nobody is trying to modify the data illegally or maliciously. So, all these things can be easily managed if you do this, right, if you have a centralized location server. But the problem is scalability. Problem is scalability. What is the problem? A disadvantage that if you want to store large volume of informations, right, large volume of informations, and if you want to access these information, let us say I want to read, you have 1 lakhs records stored in a single server model, and you are trying to search for a particular record of account number 100, let us say account number A100. So, if you want to search, what will be the, if I assume that records are not sorted, in general records are not ordered, when in a storage you store all the records of bank transactions, they are not ordered, right, because they are happening randomly across different branches. So, if you have 10,000 records, from there if you want to search for a particular record, so essentially what you have to do? You have to do searching, algorithm, right. So, what the searching program does? It traverses across all 10,000 records one by one after another, and finally when there is a account number match, then basically it finds that record and it gives as the output. It returns as an output, right. So, obviously if I do normal linear search, so on an average 10,000 by 2, on an average half of the records you need to traverse to get a result, right. So, approximately 5,000 traversals will be required to get a result, and in worst case you have to traverse all 10,000 records, because the final record which you are searching, that might be at the end, that might be placed in the end. So, therefore, in the worst case it can go to 10,000. So, therefore, now question is that two things. One is that scalability, storing large volume of record in a central repository. Second thing is that accessibility. If I want to read or perform any computations on these records, it takes a lot of time. It is taking a lot of time, right. So, therefore, can we do something, and can we do something which can which essentially store all these informations, transactions information, in a distributed system. In a distributed system means what I say, distributed architecture, you have multiple nodes, they are storing these pieces of information, not whole informations, pieces of informations in a distributed manner and in a coordinated manner. So, I am saying, let us say 10,000 records, 2,000 records in the chain is basically stored in one node, another 2,000 records are stored in another nodes, another 2,000 records stored in another nodes, and so on, but they are coordinating amongst themselves. So, therefore, now if I ask a query, a new node, it is basically searching for a particular record. So, now basically each record, each node will have some indexes. Through these indexes it knows that its query will be redirected to the respective node. So, for example, I am searching for a record of account A 500, and this is placed in third node in the network. So, query first came to the first node. Now, first node uses its index and it basically redirects the query to the respective node, that is the third node, and then in the third node only 2,000 records are there. There simply you just do the search and find the respective result. Okay. So, blockchain is nothing but a distributed ledger of records. It is basically a distributed ledger of records for various types of transactions. Obviously, in different applications, transactions in different applications are different. For example, in financial applications, transactions are like withdraw, deposit, invest, all these things, right. In case of healthcare, let us say a pharmaceutical manufacturing company. A pharmaceutical manufacturing company, it produces medicines, it manufactures medicine, and these medicines are basically delivered to different pharmacies through different vendors, and then from there basically it goes to the let us say from retail to the retailers, from there it goes to the pharmacies, and then finally it may also go to different healthcare institutes like hospitals or whatever it is. So there is a flow, of these medicine records. So different types of medicines are produced by the manufacturing company. So their informations are recorded. From there, these informations are now, some of the medicines are moved to retailers with some values. So those informations are also recorded. From retailers it goes to the pharmacies, those informations are also recorded. From pharmacies it goes to some hospitals, those information, all these informations, that what is the details of the transactions. So transaction in this particular context is different than transaction in financial applications, right. Transactions in an IoT environment, In a IoT, Internet of Things, right? There are many, you must be hearing about IoT technologies. So it is basically, you know, multiple, nodes, or let us say sensor devices. Okay, the sensor devices, they are capable of sensing various data. Okay, atmospheric data it can sense, and then basically this can be transferred through some wireless Wi-Fi, small Wi-Fi communication protocol to server for necessary computations. And these nodes can be sensor nodes, they can be networked. Okay. So in IoT systems, in such kind of system, Internet of Things we call it as. So in such systems, gathering informations of, let us say, temperature, gathering informations of humidity, air pressure. So all those by different sensors in different time periods, these informations can be also stored, and they are basically transferred to different nodes. Those records can be also stored, right? So in sensor networks, transaction is different also. So if I consider IoT, their transaction is basically storage of different readings and transferring of different readings, updation of different readings over the time. So all those things are basically the transactions. Now blockchain actually allows to store all the large volume of such transactions, large number of such records in a distributed manner. Okay. In a distributed manner, when we say, that means there are n number of nodes who are basically having some storage resources, and these data are basically stored across this n number of nodes in a coordinated manner. Now the question is that how they will ensure consistency, how this n number of nodes will ensure a consistency, because if I try to say, okay, I have